Today we're going to learn how to calculate the sum to infinity for geometric series. So if you remember last time we were looking at geometric series and those are the ones that start with a value a, first term, and then to get to the next term you're always multiplying by a common ratio which we call r. So the next term is ar, and then ar squared, ar cubed, etc. Now, if the value of r, the modulus, is less than 1, so what this means is that r could be between -1 and 1, the series converges, and therefore a sum to infinity does exist. So you can find the sum to infinity using this formula. So that means if you were adding up all the terms in this sequence, so adding up this one plus this one, etc., you kept going, eventually it would converge to a particular value. And that only happens if, like I said, we know this is true about our R value. Now you're given this in the formula booklet. So you don't need to learn it off by heart. You just need to know where to find it, and you definitely need to know that you can only use it when r is between 1 and -1. Now, if the modulus of r is greater than 1, then we say the series diverges, so we cannot calculate the sum to infinity. So, for example, that would be if r was less than -1 or greater than 1, so the kind of opposite ends of this. Okay, so let's try it in some examples. So let's say that we have this series, which is geometric, which goes 16, -4, 1, -1/4. So it's a series, and we're thinking about it as a sum. So these would be the numbers in the sequence: 16, -4, 1, -1/4. And first question would be find the sum of the first 4 terms. Well, we've already got the first 4 terms here, so we could just calculate what this is. Okay, so I typed them in, so 16 take away 4, add 1, take away 1/4, and I get 51/4, which is the same as 12.75. Then part B asks you to find the sum of the first 10 terms. So that would be S10 if I wrote it shorthand. And this is where you can use the formulas that we used in the last lesson. And because our R value, if we think about our sequence here, to get from 16 to -4 and then -4 to 1, the R must be -1/4, because 16 times -1/4 is 4, -4 times -1/4 is 1, and so on. So since R is less than 1, we're going to use this formula, A 1 minus R to the n over 1 minus R, and we learnt that last time. Now the A is the first term, which is 16, and like I said, the R you can see is -1/4, because you can kind of see they're dividing by 4 each time and the sign is changing. So 1 take away -1/4 in brackets to the power of 10 over 1 take away -1/4. And then you could just type that in, so fraction button first, and make sure you do use your brackets for the negative value of R. Okay, so we get 12.799987. 779. It asks it for 6 decimal places, so 12.799988. Okay. If you were struggling to find the r there, remember that you can always find the value of r by doing the next term divided by its previous term. So for example, you could do -4 divided by 16 to get r, which gives you the -1/4, or it would work if you chose like the third and the second term, so you did 1 over -4, which is again -1/4. Okay, then part C asks you to find the sum to infinity. So our R value is between -1 and 1, so this series does converge and has a sum to infinity. So we just use the formula and we put A over 1 minus our R. And we get 64 over 5, which is the same as 12.8. So this sequence, if it carried on and you kept adding the next term, it would just continue to get closer and closer and closer to 12.8, and then it would just stop changing. Okay? And you can kind of see that there, because in some of the first 10 is very close to 12.8. Obviously, if we keep going, the sum to infinity tells us we'd eventually get to 12.8. Okay, example 2. For this one, we are told that we know the sum to infinity is 5. And we also know that the second term in the sequence is -6 over 5. So u2 equals -6 over 5. So we use u to denote numbers in the sequence of values, and then s means sum. And the question wants us to find find the common ratio. So what we want to do with this one is we want to make some equations first using the formulas that we know. So if there is a sum to infinity, it does exist, we could write this now as a over 1 minus r must equal 5 using the formula above. Now the second term, well, like I said when we were starting off, first term of a geometric series is a, and the second one is a times r. So I could write down that AR equals -6 over 5. If I want to find out what R is, if we can make A the subject of both, then we could put them equal to each other. So A would equal 5 times 1 minus R here, and A would equal -6 over 5R there if we divided by R. That means I can put 5 bracket 1 minus r equal to -6 over 5r. I could divide through by 5 and times through by r. So basically doing a bit of swapping here. So I've got r 1 minus r equals -6 over 25. And then if I just go up here, I could expand the bracket here, so r take away r squared, and then I could add the 6 over 25, because then I've got a quadratic. Okay, so I'm going to rearrange this a little bit, and I'm going to times through by 25 and times through by -1 to make this positive. So I get 25r squared minus 25r take away 6 equals 0. Now when you get to here, you could use your calculator to solve it, to find the values of r, or you could factorise this one actually, so it would be 5r, and we need a 6 and a 1, So if you factorise it, you get r could be 6/5 or r could be -1/5. Now you need to choose which one is valid, and because there was a sum to infinity, that means r has to be between -1 and 1. So this value is not valid, as r should be between -1 and 1. So this is the correct value. Okay, final one, example 3. For this one, it says we've got a geometric series which goes like this. So 2 take away x, add 2 take away x squared, plus 2 take away x cubed, and it carries on like this. And it says it converges. Find the range of possible values of x. Okay, so for this one, if we know that it converges, we know that r must be between 1 and -1. And we've got the terms in the sequence, so we can find r. So if you remember, r is always calculated by dividing a term by its previous term. So for example, 2 minus x squared divided by 2 minus x would give me r. So this one divided by this one. And you can probably see that each time the power is just increasing. So each time you're just timesing 2 minus x by another 2 minus x. So r is 2 take away x. Now since we know it's between -1 and 1, I could put this in between there. So then to find the values of x, I could first take away 2 from all parts, so -3 minus x left there and -1. And then I need to multiply through by -1, but when you do that, the inequality signs do change. So they change to be the opposite direction. So we actually have 3 and then the greater than sign, and x, and then 1, like so. So this is telling us that x could be anything bigger than 1 and less than 3. So it could be 2, but it could also be all the values in between, so decimals and things like that. Okay, now you should be able to try exercise 4G.